Welcome to a maths class with your teacher Black Adam. We have a problem that has to deal with quadratic number pattern, and then we have 3, 7, 12 and so forth. So what we're required to do, we're required to prove the values of A, B and C on the quadratic. So the difference 3 and 7 is 4, 7 and 12 is 5, and then difference between 5 and 4 is 1. And then we need to find the next one. So 1 plus 5 is going to be 6. And then 6 plus 1, 6 plus 12 is 18. And then from there we can conclude that the second difference, which is 2a, is equals to 1. So a is 1 over 2, which is correct. It's 1 over 2. And then that should follow the exact skeleton of the original equation, which is a(n squared plus bn plus c. So we know that c is 0 because we don't have the c part on the equation given. So a is half. And now we have the first difference, that's the first term, that's 3a plus b is equals to 4. And we already know that a is half. So that's 3 bracket half plus b is equals to 4. So solving for b, that is going to be 4 minus 3 over 2. That's 3 times 1 is 3 over 2. And that, because we can see that 4 there, okay? So the base has to be 2, so we have to divide 8 divide by 2 to give us 4. And then we also have minus 3 over 2. So the base is the same, so we have 4 times 2 is 8, and then 8 minus 3, that gives us 5, and then we maintain the same base, which is 2, so it's 5 over 2. So b is 5 over 2. Now let's check the original equation given. That's correct. So c is 0, but we can also prove that c is 0 just to be certain. So we know that a plus b plus c should give us 3, which is the first term. So you should know that a plus b plus c, first term, 3a plus b is first difference, first term, and 2a is the second difference. So a is half, b is 5 over 2, plus c is equals to 3. So half plus 2 and a half, that's 3. So obviously we have 6 over 2 plus c is equals to 3. So c is 3 minus 3, which is 0. Of course, there was no 0, there was no part of c there. So I just have to calculate to make sure that we find the value of c. c is 0. Now with all the constants revealed, then we can now just confirm that Tn is equals to half n squared plus 5 over 2 n plus 0. So we get rid of the 0, and our Tn is going to be half n squared plus 5 over 2n. That's our final answer for question 3.1.1. And then we move on to the second question. So the second question says what number must be added to Tn so that Tn is going to be 13527. So we know the original equation that Tn is half n squared plus n plus 5n. I need to put the 5 there. 1 is equals to 13527. So n squared multiplied by 2, so we put in the 5. Yeah, it's not visible, so yeah, so it's going to be plus 5 over 2 n. Then multiplied by 2, we have n squared plus 5n is equals to 13527 multiplied by 2. So having those values there, we have n squared plus 5n is equals to 27054. So that is equals to 0. So we need to factor. Okay, so coefficient times that gives us 27054. We know that it's negative, so what we do, we divide by 2 to give us 135 527, and then divide by 3. See, the last number there is 27, so we can divide by 3, so giving us 4507. So dividing by 3 again gives us 1503. Dividing by 3, because you can see we have 3 in the end, and then that's 501, and then dividing by 3 again will give us 167. So 167, there's no factor for that, so that's gonna be 167. So 2 times 3 times 3 times 3 times 3 gives us 162, and then we have 167. So 162 multiplied by 167 gives us 27054. So n factoring, so we have positive 5 in the middle, so it's gonna be n plus 167 minus 162. So n, remember, it's number of terms, so it can never be negative. So n is not equals to 167, and then we have n is equals to 162. So that's the term in n, that's the real occasion. So we need to know the first difference. First difference there, we have 4, 5, and 6. And then from there we conclude that we have that's arithmetic sequence, arithmetic series or whatever. And then we have 4 plus 5 plus 6. So we know that our Tn's equation, that's a plus b, a plus n minus 1d. Okay, that's the general equation. So we know that Tn minus 1, that's what we need to find. So T161. So remember that first difference, the previous number is 161. So we punch in 161 there in the original equation for first difference to give us first term there is 4 plus 161 minus 1. A common difference there you can see is 5 minus 4. That's common difference is 1. 5 minus 4, that's 1. So we're gonna put 1 there. So putting 1 there, we have T161 is equals to 4 plus 160, giving us 164. So 164, that's our answer. That's it. So that's our answer for 3.1.2. So we move on to another question. So the question says, given an arithmetic sequence, T1 is 8, T2 is, I said 1.1, it's supposed to be T2 is 11, and then we have T1 is equals to 8, and that's supposed to be 11 there. So T2 is going to be 11, and then we have D there. Difference is T2 minus T1. So that is going to be 11 minus 8, giving us 3. And we also know that we have Tn is equals to a plus n minus 1 multiplied by d actually. So T4, okay, we have T1, Tn, we told is 41, a common difference d, and then it's 8 plus n multiplied, and common difference is 3. So solving for n, there will be 8 plus 3 times n, 3 times negative 1, which is negative 3, and then we have 8, and then 8 minus 3 is 5 plus 3n. So solving for 3n is going to be 41 minus 5, and then n is going to be, for 1 minus 5 is going to be 36. So n is 36 divided by 3, that is 12. So n is 12. So that's our answer for 8.2. And then we move on to the next question. Okay, so the n is the 12th term of the arithmetic sequence. So moving on to the information, given that P8 is 1 and P11 is 2 and so forth. So you can see that we're adding by fractions there. And then the term value of the given arithmetic sequence, So P, they say P41. We already calculate P41. For 1 mark, no calculation needed. That's P41 is 12. So we move on to the next one. The value of the first term of the new arithmetic sequence. Remember, we're given the values. The values we have T8 is equals to A plus 7D. So we put on general formula there. A plus n minus 1 multiplied by D. So 8 minus 1 is 7, so T8 is 8 plus 7D, T11 is 8 plus 10D, that is equals to 2, and T8 is equals to 1. So we need to subtract, because you can see we have common values there, which is A. And then subtracting that, we'll have A plus 10D. Usually it's the big one minus the small one, but either way is fine. And then A plus 10D is equals to 2. And then we have a T8, which is A plus 7D, which is equals to 1. And then from there we subtract. So we know that 2 minus 1 is 1, and then 10D minus 7D, that's 3D. And then A minus A is 0. So the A part disappears. We have 3D is equals to 1. So the bottom part there is T11 minus T8. That's what we got. And and then the other thing, we have 3D. Okay, 3D is equals to 1, and D is equals to 1 over 3. So we have D there, 1 over 3. So remember that we need to solve for A. So solving for A there, we have to use the original equation, any equation of whether T8 or T11. So I think it shows T8, so A plus 7D is equals to 1. And then we're solving for A, substitute D, so 7 bracket, D is 1 over 3. So 1 over 3 is equals to 1. And then A will be 1 minus 7 over 3. So to make 1 there is 3 over 3 minus 7 over 3. So we just subtract the top part. Remember, 3 over 3 makes 1, So you're not changing anything. Just look at the denominator on the other side, then we change the other side to have the same denominator, but maintaining the same value. So 7, difference between 3 and negative 7, that's negative 4 over 3. So that's our answer. Our A is negative 4 over 3. Thank you so much for watching, and don't forget to subscribe, or for any question please leave below and I'll come back to you. Thank you.